Once again, good morning everyone. Still only 40 students are joined. I told you many times, please join at least 5 minutes before any class. Any class, please join 5 minutes before. Then it is good. At least 1 minute before. Okay. Because it is a virtual class, right? Right. Okay. Now, tell me what you are discussing in the last class. What is the last class discussion? Anyone, please?
Linear data structure.
So we have started linear data structure. Okay. I think I given some questions to you, I think, for arrays. In linear data structures, arrays is the also a linear data structure. Now already arrays is there. If arrays is there, why should we go with the linker list? That's why we must know what are the disadvantages of arrays. Tell me, I given 3 or 4 questions, right? Tell me, what is that? Anyone, please? Please respond fast. What are the drawbacks in arrays? No one is responding. If just you are opened the class, just you are putting on, then you are following. You are doing the things because you are not responding. Is this my voice is audible? Is it my voice?
Yes, sir.
Yes. Yeah, my question is very clear. Even we discussed in the last class. If we are going to respond, then only I will continue. Otherwise, what is the use? Unnecessarily, we are wasting time. Here, I am telling very clearly what are the drawbacks in arrays. Already we discussed in the last class. Anyone, you can unmute your mic, you can tell. What are the drawbacks in arrays? Anyone? If you are not responding means you are not understanding my class. Please tell me anything is there, I can change, I will change the faculty. Already I told you earlier. So this is very important subject. Here you must follow the things. If you are not following, classwork, any classwork, please inform to me, even my class also. Already I told you, write the points. Please use notebook and pen. Write what are the points I am going to tell. You must write. Then you have to revise them before coming to my class. What are the drawbacks? Tell me. In arrays?
So we cannot change the size of an array.
We cannot?
We cannot change the size of an array
Yes. Yeah, because the guides also telling said, yeah, the size is fixed because it is a static nature. That's why after initialization of the size of that particular array, I want to add some elements. It is not possible. Even we want to delete, yes, difficulty. Yes, correct, Gayatri. She is typing some message. But instead of typing, maybe try to unmute your mic, you can speak. Because when I am sharing screen, that messages are not visible. Just I am minimizing my presentation. That's why just it is visible. Okay. Here, very clearly we discussed in last class, here arrays, if you know arrays drawbacks, then only we can understand importance of the lists, linked lists. Otherwise, we cannot understand. That is the thing. Here, already I told you, when we are going to declare any array size is, if we are going to declare 4, the elements are inserted like this, 3 and 4. Now, here any element I want to insert middle, it is not possible because size is fixed. Here any element you want to delete also, it is not possible. Okay, because array is going to store the elements in a sequential fashion. Means the elements are going to store in a sequential addresses. That means when I am going to declare int a of 4, now it requires 4 contiguous memory blocks. Means here in your RAM, it requires 4 contiguous, means sequential blocks are required, contiguous, until unless your operating system is going to search 4 contiguous blocks. If it is not there, for example, memory blocks are like this, 4 contiguous blocks are required. For example, okay, this block is already occupied. This block is already occupied. Now tell me, in your memory, is there any 4 contiguous blocks? Now I declared int a of 4. Now a requires 4 contiguous integer blocks. Now in this my memory, 4 contiguous blocks are available. Is it visible?
Yes.
Yes, sir.
Yeah, why you people are not responding? This section, please try to respond. If it is understand or following, not answer, right, wrong, whatever it is, you must respond. Now tell me, 4 contiguous blocks are available in this memory or not?
Yes, sir.
4 contiguous blocks are there in this memory? Tell me.
No, sir.
This block is already occupied by some other data. This block is already occupied. Here for int a, if I am going to write, 4 contiguous blocks are required. Here, is there any contiguous blocks? Here, one is there. After one, first block, there is no other block. There is missing contiguous block. Okay, we can start from here. 1, 2, 3, 4. Yes, it is there. Here, from here, it is going to allot 1, 2, 3, 4. Yes, contiguous 4 blocks are available. For example, if this is already filled with some data. Now, in this memory, is there any contiguous blocks?
No.
No. Sure, no. Then operating system cannot be alert. But we are using very small programs. Academic programs are very small. We are not implemented a real-time program. That's why you are not facing this problem. When it comes to the real time, there are a lot of variables you have to use, very big programs you have to write, real-time applications when you are going to write, it requires more memory. At that time, we cannot get contiguous blocks sometimes if we are going to use unnecessarily. Now there is no contiguous blocks. Then when I am going to declare int a, now compiler cannot allot the memory. It means compiler is requesting to operating system. Operating system cannot allot the memory. Yes or no? Yes or no?
Yes, sir.
Yeah. Here now there is no contiguous blocks. Now, but 4 number of empty blocks are available or not in memory? 4 empty blocks are available or not? Dear students, you respond it. Otherwise, I am going to close the class.
Yes, sir.
Why you people are creating this much of wasting of my time? Yeah, please respond. Yeah, I am asking questions. Already I told you, your classwork is not for one-way direction. Otherwise, I will share a section. Already I completed this task. I will share the recording to you. Then you can watch. There is no question. There is no answer. I am asking you. No one is responding. What is this? Ridiculous. It is not a good thing. I don't know. You people, how you people are doing this, I don't know. how you are habituated your first year, I don't know. But the thing is very clear. Here, my sincere request and suggestion. Here, please respond and ask the doubts and discuss. Here, this is not like a one-way thing. You must be discussed and you must be asked the thing. Then only it will be clear. This is a technical subject, not a technical subject. Right. Now tell me, now empty blocks are available in this memory or not? Minimum 4?
Yes, sir.
Yes. Here minimum 4 blocks are available, but you are not accommodating. Yes or no?
Yes, sir.
Because arrays are required contiguous blocks. So that's why here memory is there, but you are not allocating. Here this is the drawback, very big drawback, because it is a contiguous blocks. Correct.
Yes, sir.
Then here these are the drawbacks you have to consider. Now they are implemented linked list. Your linked list is a dynamic nature. It never be follow the contiguous blocks. Now 4 blocks are there. Okay, you take this block, take this block, take this block, take this block. Now it is going to allot. Yeah, that's why here we are going to overcome this arrays problem with help of linked list. Here, this is the advantage of the linked list. That's why we need a linked list. We can add element anywhere, beginning of the list, last of the list, middle of the list, wherever you want, you can allot. Whenever you want memory, you can dynamically, you can create your memory, then you can allot. Yeah, that is the advantages are there when you are going to observe lists. Okay, that is why a lists are going to provide more flexibility. But here lists are not a predefined data structures. Arrays are predefined data structures. Just we can write int array of whatever size you want. But lists are not a predefined data structure. It is a user-defined data structure, abstract data types. Then we have to create. Are you clear now?
Yes, sir.
Now we are going to understand linked list. Here, what is linked list? A linked list is nothing but a simple thing. Linked list is nothing but it is a collection of nodes. A node means don't confuse. Node is nothing but a memory block. Are you clear? Node is nothing but a
Memory block.
Memory block. That is what simple. Node means don't confuse. In data structure, we are going to call it is a node, but that is nothing but memory block. Here, linked list also it is a, already I told you, it is a linear data structure. Okay, means elements are going to arrange in a linear fashion. Not it is following a contiguous memory blocks. Linked lists are going to arrange the elements in a sequential structure, one by one, one by one. Yeah, that's what you can tell. A linked list is nothing but a collection of nodes. The node is nothing but a memory block. For example, here now I want to arrange data. The first node is like this, means memory block. Here after that, one more data I want to arrange. Now it is going to connect it to this. Next memory block. We are going to connect to like this. Like this. Here you are connected first memory block, connected to next memory, data is stored, next memory, data is there, next memory. Like this, here we are going to arrange the nodes in a sequential fashion. That is called as linked list. Are you clear this definition? Are you clear everyone this definition?
Yes, sir.
Yeah, linked list is nothing but it is a collection of nodes which are going to arrange in a sequential fashion. Sequential fashion. That's why it is a linear list. Okay, clear? Clear?
Yes, sir.
We have different types
Yes,
of
sir.
linked lists. As per your syllabus, the first one is the single linked list. Here, what is single linked list? The single linked list is nothing but here every node contains only one link. First of all, remember, here single linked list also a collection of nodes. But every node contains only one link. Link is nothing but an address. Are you clear? Single linked list is nothing but it is also a collection of nodes. Okay, but what is the single linked list? Here every node contains only one address, only one link, single link. That's why it is called as single linked list. Here next topic is double linked list. Means that every node contains two links. That is a double linked list. Okay, now single linked list, nothing but every node contains one link. I will tell you what is link, what is this. First of all, you must be aware this definition. Are you clear now? Single linked list means?
Yes, sir.
Please, everyone, all 60 students of your class, please understand the single linked list concept and program. I will explain how I am going to explain. Same way I have to write the program. Here, if you are going to understand single linked list program, total complete data structure is very easy. Total data structure you can understand. What total subject you can understand. Total all programs you can understand if you are going to understand single linked list. Please, that's what I am giving more, I am putting more efforts. Please, you also put more efforts for this single linked list. If you are not understand, you ask again, I will tell you again and again, not a problem. But next topics, 100% it is depending on single linked list. If you are really everyone practice single linked list, how I am explaining the same way, you can understand remaining data structure. This is my sincere request and order. Here, otherwise, you are going to fail in this subject. If you are going to understand the single linked list, you will get 100 marks. Simple. Only two stories. 100 marks, fail. Right? There is no in middle or average. And without these data structures, there is no any question from placements and any software company job, no software implementation. Already I told you very clearly. But understand, ask. And response is very, very important too. Okay. Now, single linked list definition is nothing but it is a nodes, collection of nodes which are going to arrange in a sequential fashion. But every node contains one link. That's why it is a single linked list. Are you clear now?
Yes, sir.
Yes, sir.
Yeah, as per the definition, sir, already I told you it's a collection of nodes. Now, first of all, as per the discussion of previous class, already I told you abstract data type. Your abstract data type. What is the meaning of abstract data type? Again, I am calling here. Simple question I am going to ask, you must respond. If I wanted to calculate C equal to A plus B, then I have to declare into A, B, and C. Correct?
Yes, sir.
Yes, sir.
Right. Now, here when I wanted to declare into A, B, C, I am not thinking and I am not bothered about how much memory is going to allot, who is going to allot, what is the structure, what type of data it is going to take. All these things I am not bothering. Yes or no?
Yes, sir.
As a programmer, you are just not bothering. Just you are going to declare. Yes or no?
Yes, sir.
Yes, sir.
Because these data types already declared by, already provided a definition by our compiler, that particular programming language compiler. Yes or no? If you declare float, char, whatever it is, we are not thinking about the memory.
Sir, yes, sir.
Yeah. Now this linked list is we are going to preparing for our purpose. Yes or no? Then operators, your compiler doesn't know how much memory is going to allot, what is the structure is required. Yes or no?
Yes, sir.
You have to create that structure. You have to tell to compiler, okay, this much memory is required and this type of data it is going to accept. This is the structure you have to specify when you wanted to use that particular data type. Yes or no?
Yes, sir. Yes,
Now
sir.
for that data structures is called as abstract data type. Means that structure we have to prepare first. Means when we have to use this single linked list, that node structure we have to prepare first. And that is called as abstract data type of single linked list. Clear? So after creation only we can use wherever you want that particular structure. How we are using integer, float, char, same way you can use. First of all, you have to prepare the abstract data type. Are you clear now? The point is clear?
Yes, sir.
Now, as per the single linked list definition, here already I told you, single linked list contains only one link. Means in the single linked list, node is divided into two parts. Please understand the things. Your node is divided into two parts. So two parts means one part is going to store data. So this is for storing the data. Anyway, you have to store, right? Into A means what purpose you are using A? A you are going to assign A equal to 10 means A is going to store 10, right? So for that, the first part, the structure of single linked list node is divided into two parts. The first part I am using for to store the data. Are you clear? The second part is using to store the address of next node. The second part I am going to use to store the address of next node. That's why I am going to declare as a pointer. The pointer name I am taking next. You can take any name, not a problem. Are you clear? Node is divided into how many parts in this single linked list?
Two types.
Two types.
Two parts, not
Two
types.
parts.
Not
Two
types,
parts.
please. Two parts means what we are doing. Memory block we are dividing into two parts. Node means already I told you it is a memory block. Now this memory block, I am preparing my structure. Already I told you because the single linked list is not a predefined one. Single linked list I am creating. That's why first of all we have to prepare the ADT. This is ADT, abstract data type. Now I am preparing the structure I want to use. For example, I will tell you. For example, if you want to arrange your all belongings into one home, that is a rented one. Here, when you are going to move that rented one, already structure is prepared, right? You are not going to create any structure of that rent house. Yes or no? Yes or no? You
Yes,
have to
sir.
follow the structure. Where is the kitchen? You have to arrange all items in the kitchen. Because already it is structured, already it is prepared. Just we are going to give the rent, we are going to arrange our data, whatever the items we have. Yes or no?
Yes, sir.
But when I am trying to construct my own house, we are going to construct your own house, then you have to construct very clearly here where is the kitchen, how it is required for us. Here, this is the hall, how to arrange this hall, what is the designs, everything you have to prepare. Yes or no?
Yes, sir.
After that, you can use. First of all, you have to construct, then you can use. But when you go to rent house, here you are not going to construct, just you have to use. Is it right?
Yes, sir.
Yes, sir.
In the same way, predefined data structures, a data type, the programming language, whatever the data types they are providing, you have to use directly without thinking of construction, without thinking of anything. Yes or no?
Yes,
Yes,
sir.
sir. Now comes to your own house construction. You have to construct as per your requirement. After construction, you can use whenever you want. In the same way, here, your data structures, now user defined data structure. First of all, you have to construct your structure. That is ADT, abstract data type. After construction of this ADT means, construction means what is the structure for that data type and what are the data and what is the memory it is going to allot. Okay, this is your job. After that, you can use that particular node wherever you want, like integer float like that. Are you clear now? Is it clear? This point is clear?
Yes, sir.
Yes, sir.
Now, before using this node, just I am constructing. Now, in this single linked list, the node is divided into two parts. I am dividing this node, this memory block into two parts. One part is for storing the data. This is ultimately, we have to store finally the data in a memory. That's what the first part is for, storing the data. The next part is for what purpose I am using? To store the address of next following node. Sir, no pointer. What is the meaning of pointer? What is a pointer?
It's hold the address of the variable.
Another variable.
It holds
Correct?
the address of the
Address of another variable. In the same way, here I am using pointer. This pointer is going to store address of another node. Address of another node. Because here when I observed the linked list, what happened? Your first node means data is there. Next it is going to connect it to the next node. Means it is going to store the address, this address to first node. Like that, your next following node will come. That node address we are storing here. Then if you know the first node, then we can move from first node to second node to third node to fourth node. Because single linked list is a linear data structure. Linear means one by one. Sequentially, we are going to arrange the data. Now clear? Now understood? ADT of single linked list is clear?
Yes, sir.
If someone will ask what is the ADT of single linked list, simple, you can tell node is divided into two parts. One part is for storing the data, another part is for storing the address for next following node. Clear?
Yes, sir.
Yeah, that's why data and link. This is the two parts. Okay, clear now? Clear now?
Yes, sir.
Clear. Now just we are going to check how linked list is there. This is the one node. If you are going to construct a single linked list, how it is? I am just here constructing the first node and the second node. This first node here data part I am storing then, and this address part is going to store address of next connected node. This here you have to remember in your predefined data structure we are not thinking about the addresses, just you are thinking about the data, but here you have to remember addresses also because it is not a contiguous. Okay, you have to create the memory, you have to allot the memory, you have to connect the things. That's why here you can understand very easily if you are going to understand single linked list and my flow you must understand and practice. How I am writing here is the same way you practice in your notebook. Now the second node data is 20. Now third node I am constructing 30. This node address I am storing it previous node. Right. Now fourth node. This is 40. Now this node address stored into its previous node. Right. Now, like this single linked list is there. If you observe single linked list, every node contains only one link, right? That's why it's a single link. Link is nothing but a address pointing to next node. Are you clear now? Understand this?
Yes, sir.
Like this we have to construct. Now, when you are going to construct single linked list, you must be note down two important points. You must be note down two important points. The first point is always single linked list start from first node, that is called as start or head. Always the single linked list is going to start from first node. Here that is called as start and some people will call head. I am going to call start. Okay, all programs. You can take any pointer, right? You can take any name, not a problem. People will generally call start or head. Yeah, that's a pointer. You can take S also, not a problem. No one will ask. Ultimately, the program has to execute. Okay. The next one is the how to identify the last node. Always the last node which is going to points the address part is null. Yeah, these are the 2 points we have to remember. Okay, I will tell you one by one. First of all, what is null? Anyone can tell what is a null? Please respond immediately. What is null?
It is the end, sir.
No. Means maybe we are using for end, but not exactly what is the exactly meaning of null. Anyone?
Zero.
Empty.
Empty. Zero.
No value.
Empty means how you can tell empty? How you can tell empty? How you can tell zero? This my question is very straightforward. How we can tell it is empty? How we can judge that room is empty? How? Okay, I will ask one question.
If the
No
next
problem.
array is not there.
Next, tell me next.
If the next data is not there, it will take the last one as the null.
Okay, I will tell. I will ask one question, generalized question. Then you can understand what is exactly null. If people are confusing with null because this null is very important. All subjects null we are using. If you understand my meaning, then you can apply everywhere same. Because you are a software professional, you must know the null. Very important. Okay, what is null? Before that, general question I will ask. For example, if I tell you, please go and verify how many students are there in the classroom number 1 or 2. If I tell what you will do, you don't know that 1 or 2 classroom is existed or not. You are going to start from 1 because you don't know. Okay, you are the new guy. Like a sequential, okay? You are going to start 1. Then tell me, How we are going to tell how many students are there in 1 or 2 classroom number? General question I am asking.
Sir, by counting the number of students
My question is clear?
in that room. Yes, sir. Hello.
No. You don't know the room numbers. You are starting from 1. You don't know 1 or 2 is existed or not also you don't know. You have to move one by one. Means how we are going to move? First we are going to verify room number 1. You are not entering room number into that room. Just we are going to verify that room number outside of the door. Okay, this is 1. Then we are moving to. Yes or no?
Yes, sir.
Yes, sir.
Until unless we are going to find the 1 or 2. Correct?
Yes, sir.
Yeah, after entering 1 or 2, then you are observed, okay, it is 1 or 2. Then you are entering inside, then you are going to count how many students are there, then you can tell. What you can tell? If there is no student, what you are going to tell? Room is
Absent.
empty or 0. If any student, 1 or 2 students are there, you are going to tell 2 members, 3 members. Yes or no?
Yes, sir.
Yes, sir.
Room number 1 or 2 is existed. Correct?
Yes, sir.
If I tell room number 501, 501 is not there, but you also don't know, you are going to search from 1 to 500. Yes or no?
Yes, sir.
Now, if I tell 502, how many students are there? What you are going to tell? What is your answer?
The
You are
class
going to tell
doesn't
empty or
exist.
0?
The class doesn't
The
exist.
class?
Doesn't exist.
The room is not allotted. Here, null is nothing but not defined. Null is nothing but
Not
what is the meaning
defined.
of null? Not defined. If you tell 0 means something is there, memory is allotted. If you tell empty, memory is allotted, room is there. But I am telling there is no room. If you are allotting unnecessarily, because I don't want to store any data, what is the need of room? Yes or no?
Yes, sir.
Yeah, here this is the meaning of null. Null is nothing but a not defined. There is no memory block is allotted. Are you clear?
Yes,
Yes,
sir.
sir.
Yeah, this is the meaning of null. Please remember this. Not 0, not empty. Please. That if you tell 0, memory is allotted. If you tell empty, memory is allotted. If you tell something also, memory is allotted. Only the thing is room is not existed. Means only null means it is not defined anything. There is no memory allotted to for that particular pointer. Are you clear?
Yes, sir.
Are you
Yes,
clear?
sir.
Yeah. Now,
Yes, sir.
when we are going to prepare single linked list, we need 2 points. The first point is always you must start from the first node. Here, this is a first node I am feeling. This I am calling start. Okay. If I know the first node, that is a start pointer, I am pointing. Means one pointer is required. That is a start pointer or first pointer or any pointer name you can take. This pointer is always pointing to the first node of a single linked list. If I know the first node, then I can move first node and I can read the data 10. After 10, what happened? This node contains address of next node. Yes or no?
Yes, sir.
Then we can move from here to here. Again, I am going to read 20. Then this node contains address of next node because it is sequential, already I told you. Then you can move to next node. Now 30 I am going to read. After that, this node contains address of next node. Yes or no?
Yeah, yes, sir.
Yes, sir.
Now 40 I am going to read. Again, this node contains address of next node. Now I don't know this next node is there or not. Here, when I know when the node which is going to read null, the node which is going to read next part is read null, then I can tell that is a last node. That's the second point. Always next part of the last node must be null. Are you clear? How to identify
Yes, sir.
last node? The node which contains next part is null. That is a last node. Yes or no? Otherwise, here if you are going to observe in a single linked list, only one last node is there. Only one node contains next part is null. Null means it is not defined. Are you clear now?
Yeah,
Yes.
yes, sir.
Yeah, please remember. Here, start pointer always pointing to the first node. The null, the node which contains next part is null. That node is contained. That node is called as last node. We are not providing any pointer for last. We are not going to represent. If you are representing means memory is wasting. That's why we are not going to represent. You can understand the last node always contains next pointer is null. Are you clear now? Understand?
Yes, sir.
Yes, sir.
Yeah, this is a single linked list representation. This is only the representation, how to represent single linked list. Here in the same way, here already the diagram is there. If you are going to understand, this front is going to show the first node. This node contains data part and address part. This address is nothing but next to following node address. What is the next to following node address? 1004. Yes, we are stored here like this. The next to node address. Next to node address. The last node always the next pointer contains null. Clear now?
Yes, sir.
Yeah,
Yes,
yes,
sir.
sir.
Yeah. Now we are going to discuss about the operations on a single linked list. Here we are having three operations: insertion, deletion, and display. Here, what is the insertion? Insertion is nothing but we are going to insert a node. Here in arrays, it is not possible. This is the problem, right? Once we are going to declare any linked list, any array, if you want to insert any new element, maybe the first, maybe the middle, maybe the last, wherever you want to insert, it is not possible. But in a single linked list, you can insert. For example, I will show you very simply. Here now I want to insert 50. The node is created 50. So this is a new node I am creating because already this ADT is there, right? Just you have to call this ADT. Yes or no? The structure already prepared, right? No need to write again. No need to create the structure again and again. Once you create, you can use it everywhere. Are you clear? How to create?
Yes, sir.
I will tell you programmatically. Don't worry. First of all, understand the theoretical. Clear now? Now node is created. Okay, that node data is 50. Okay, new node. Okay, now it is a null. Okay, this is a new node I am taking. Now I want to insert this new node somewhere. Where you want to insert? For example, you want to insert after 20. Are you clear?
Yes, sir.
Now, how to insert? Simple. Here, this 20 node next part contains what? It is address of 30. Instead of storing address of 30, you store your address of 50. Clear? Clear?
Yes, sir.
Now, this node, 50 node, the next part address contains null. Instead of storing null, you replace with 30. What happened? Now we are inserted. Just you check from start, here 10, 20. After 20, what it is going to move? It will move to 50, not 30. Yes or no? Because you are replaced 30 address with 50. Yes or no?
Yes, sir.
Yes, sir.
After 50, we are moving to 30. After 30, we are moving to 40. Yes or no? We are inserted. Wherever you want to insert, you can insert in this way. Just you are going to replace that addresses and you have to connect wherever you want. Understand?
Yes,
Because
sir.
it is not a contiguous memory block. Tell me, someone is
Yes, sir.
asking. Yes, tell me, one girl is asking something. Is it clear, everyone? Is it clear,
Sir,
everyone?
can you once repeat, sir, please?
Simple. Here, initially what happened? Here, start at 10. After 10, 10 is going, this node is going to store address of next node. Yes or no?
Yes, sir.
This 20 is having in the address part next node address. Like that, 10, 20, 30, 40 is there. Now I want to insert this 50 node, new node, because it is not possible in arrays. But I told you already single linked list it is possible. Now I am discussing single linked list. In that it is possible wherever you want to insert, you can insert. Whatever the node you want to delete, you can delete. Just graphically I am showing here how to do that. Here now 50 is created because already ADT is there. You are created 50 node, new node. Yes or no?
Yes, sir.
Yeah, programmatically I will tell you. Don't worry. Graphically you can understand first. Now 50 is created. Now where I want to insert, after 20 I wanted to insert. Here this is a single linked list. Here 10, 20, 30, 40. But after insertion, what I want? 10, 20, 50, 30, 40 I want. Clear? Clear?
Yes, sir.
Yeah. Now initially what happened? This 20 node contain address part contains 30 node address. Yes or no?
Yes, sir.
Then you can replace this 20 address part 30 to 50 node address part. Then this connection is going to close. It is going to connect it to 50. Clear?
Yes, sir.
Now here after 50, what you wanted to connect 30. But initially what happened is 50 next part contains null because it is a new node. Now this chain is closed, but we have to connect. How to connect? Here this address part you replace null with 30. Now it is going to connect it to 30. Are you clear?
Yes, sir.
Yes, sir.
Now what happened? It is connected in middle. Here, where you are going to start? From start pointer, we are going to start your linked list 10, 20. After 20, it never moves to 30 because this address is stored,
50.
replaced with 50. Then 20, it moves to 50. 50, then it moves to 30. Then 40. Because it is not a contiguous memory blocks. Already I told you very clearly, your arrays are going to follow contiguous memory blocks. Linked list never follows contiguous blocks. Here, wherever the memory block is required, automatically it is going to use because we are storing addresses. Arrays, we are not storing the addresses. We are just following the sequential memory blocks. But here, whatever the block you have, you can use the addresses, you can manage. Are you clear now?
Yes, sir.
Yes, sir.
Yeah, this is insertion operation. If you come to the deletion operation, any node you want to delete, are you clear? Any node you want to delete, you can delete. For example, I want to delete that 20. How to delete? Generally, what is the basic structure? 10, next it moves to 20, next it moves to 50, next it moves to 30, 40. But after deleting 20, what structure you can expect? 10, after 10, it moves to 50, then 30, 40. Now, how to avoid this 20? Simple, the logic is very simple. The 10 node address part contains what address? 20 address. Yes or no? Yes
Yes,
or
sir.
no?
Yeah, yeah.
Instead of this 20 address, you replace with 50 address. Then the link is going to close. It is going to connect it to directly 50. Are you clear?
Yes, sir.
Yes, sir.
Then after you free it, means delete this node. Yes or no?
Yes, sir.
Just you are replaced addresses. After that you delete this. Now what happened? 10 after 10 it is moved to 50. After 50 it moves to 30. Now node is deleted. Clear? Clear?
Yes, sir.
Yes, sir.
In this way, you can delete any node. In this way, you can delete any node in a single linked list. In this way, you can insert any node in a single linked list. Are you clear? Are
Yes,
you
sir.
clear this? Yeah. Now display is nothing but we are going to print the elements. Means 10, 20, 30, 40, whatever the order you have, you can come. These are the three operations we are going to discuss in a single linked list. Okay. The first operation is insertion. Right, first operation is insertion we are going to discuss. Here before discussing insertion, already I told you, here now coming to the implementation. Now just critically we discuss it now. Now come to the implementation. Programming also I am going to discuss here. Please follow and write the notes. All these notes you cannot have in my notes. In this presentation PDF, I cannot, I will share this, but you don't have all these points, whatever I am explaining, real-time examples. Please try to add, try to practice, then only you can understand. Right. Now, already I told you, when you want to implement this single linked list, first of all, you have to create the node, right? ADT, right?
Yes, sir.
Yes or no? Yeah. For that, now we have to perform this insertion, deletion, display. First operation is the insertion. Here, first we want to perform insertion operation. We have to create a node. Please fast replay is required. At least we have to insert at least single insertion. Okay. First node. Here a node I have to create. Here node is divided into how many parts? In a single linked list?
2 parts.
Yeah, good. 2 parts. Here that's why the first part is what purpose we are using?
Storing
Storing the
Storing the
Storing the
data.
data.
Yeah, good. Here for that, here I am creating a structure and structure name I am taking node. You can take any node. Are you clear? You know how to create the structure. Yes or no?
Yes, sir.
Yeah, the structure name is node. Here I am taking as a name node. You can take any name, not a problem. Okay, structure node. For this structure, how many parts I need? 2 parts. One part is for storing the data, which I want to store integer. For example, I want to store integer. Are you clear? Are you clear?
Yes, sir. Yes, sir.
That's why here I have declared inside of the structure int data. Now this is for data variable. Sorry. Yes or no? It is a data, right?
Yes, sir.
Now which is integer. If you want to store this data as a character, you can declare char. If you want float type of data you want to store, you can use float. Whatever the data type you want to use, you can use. Correct? Correct.
Yes, sir. Yes, sir.
Now I told you just now next part in this block is we are using for storing the address of next
The
node. Yes or no? Storing the address of
next.
Next
next
node.
node. Next following node. Yes or no?
Yes, sir.
Yes, sir.
It is going to store. Means it is a pointer which is going to store the address of next node. Here, now this is the next pointer I am declaring, which is struct node type. Why it is a struct node type, I will tell you. Now this next node, this variable, pointer variable is going to store which type of data? Which type of data it is going to store?
Integer.
No. How integer, yeah? For example, I will tell you. Int A equal to 10. A equal to 10. If I am going right, A equal to 10. Here A is going to store which type of data it is going to store A? If I assign 10 to A, then what type of A is what type?
Integer.
Integer.
Integer. If I assign A equal to 10.3, then what type A is what type?
Float.
Float.
Float. Right? Clear? Now clear?
Yes, sir. Yes,
sir.
sir.
Now this next variable, pointer variable, I am going to store what type of data here?
It may be a integer or a
What type
float or a
of?
char.
What is the meaning this pointer? This next pointer is going to store address of next following node.
Yes, sir.
Yes or no? We are storing address of next following node. Okay, node is which type? We don't know because we are preparing this node, right? This is a node. Yes or no?
Yes, sir.
Yes or no? Node
Yes,
is
sir.
which type now?
Yes, sir.
Struct to node type. Node is which type? Here I am preparing struct to node type. Yes or no?
Yes, sir.
Whatever the node we are going to connect here, that node address we have to store in this next pointer. The node is which type? Struct to node type.
Struct.
Yes or no? Structure node, structure node. Yes or no?
Yes, sir.
Yes, sir.
Now this structure node type is a node type. That's why here we are storing the address of this new node into next pointer. Then next pointer is which type? Struct node type. Are you clear?
Yes, sir.
For example, this 20, this address part is storing this 10 address part is storing this 50. This 50 is a node type, right? It is not an integer type. It is a node type, right?
Yes, sir.
Yes or no? This address we are storing in this pointer means this pointer also which type? Struct node type. Clear?
Yes, sir.
Clear. Now that's why here my structure contains two parts, because my node contains two parts. One is integer data, another one is the struct node, because this pointer is going to store the address of next following node. Are you clear now? How to write the IDT? Now understand?
Yes, sir.
Yes, sir.
Now I prepared my structure. Wherever I want to use, I can create object. I can use that object. Now here two ways we can create the object for structure. Inside of the structure, how to write? Here like this: star start equal to null. Initially there is no node. That's why I'm assigning null. Are you clear now?
Yes, sir.
Initially there is no node. For example, if you went to classroom, beginning no one is there, you are the first person. Now null, right? It is no class. That's what start equal to null. Star start equal to null. Means start is what? Object of the node, the structure. Yes or no?
Yes, sir.
If you want to declare, if you want to create object outside of the structure, how to write? Simple. Here outside of the structure I am writing. Struct, my structure name is what? I have taken node, right? Node, outside of the class I am writing. Now, for example, I am taking a pointer is nn. Here, nn is what? Nn is a node. Yes or no?
Yes, sir.
Which is this structure type. Here, this node nn is contains two parts, data part and the next part. Yes or no? Here, outside, this is outside of the structure. Yes or no? I am creating object nn for this structure. Here, if you wanted to create object inside of the structure, yes, you can use without specifying struct directly node. You can write directly the object name. Correct? Is it clear now? Is it clear?
Sir, I didn't understand that, sir.
What? What?
That star start equal to null.
Okay. Now, why this null? Just I will tell you. First of all, understand how to create object of structure inside. Directly, you can write before semicolon. You can write star start. Means this is the object of node. Yes or no? Yes or no?
Yes, sir.
I will tell you
Yes,
now
sir.
later. First of all, understand how to create the object inside of the structure. Here, inside of the structure, you can write star start. If you want to write one more object before semicolon, you write star nn also here. Yes or no? After you can put semicolon. Yes or no?
Yes, sir.
Now, if you want to create object outside of the structure, how to write? You have to specify outside of the structure. Means after semicolon, if you want to create any object for structure, you have to write struct node and your object name. Correct?
Yes, sir.
Like how we are creating integer like that, int a. Same way, here this is a your data structure and this is a variable. Int a, float a, char a, like that. Struct node star nn. This is a object name. Here this is your data type. Are you clear now?
Yes, sir.
Everyone, is it clear?
Yes, sir.
Is it clear? Yeah. If it is clear, then here why this start equal null, we are assigned null. Here initially when we are going to start your program, here any node is created. Before coming to college, do you have any classroom for you? Before joining admission, before admission of CMR, do you have any classroom? Do you have any space? Do you have any alternate number? No, not defined. Now, here before starting, I don't want to allot any memory for you. I don't want to allot any alternate for you. Same way, before starting of your program, the particular structure, the basic start object is null or not initially.
Yes, sir.
Yes, sir. Yes, sir.
That's why initially I declared start equal to null. Initially, because initially there is no start, right? There is no first node, there is no first student. Then automatically it is a null. Yes or no?
Yes, sir.
Initially. Later, when you are adding, you are replacing this null to your memory. Your memory, new node, you are allotting. Next node, next node, next node, you are allotting. Are you clear now?
Yes, sir.
Ah, yeah, please. Anything is there, you ask. Because this, you know how I am preparing this data structure and ADT. Then later, I don't want to work more. You also don't want to work more. You can understand, oh, this is what. Then automatically you can prepare. I will tell you structure, you can prepare, you can write the code. That is the advantage for the single linked list. That's why this many times I am telling. Even if you are having any doubt, also you ask here only. Ask. Asking is very important, please. Right. Now ADT is ready. Now ADT data structure is prepared. Now we are going to use for that. Here now the first operation is insertion operation. Here you can insert a node in three ways. You can insert a node in a three ways. How you can insert means if I want to insert a new node in beginning of the list, yes or no? Because I am reducing the complexity of the program. Only one program I can write everything. You can confuse. I am dividing the program into multiple blocks. Okay, multiple functions. Then you can easily understand. Now you can insert a node in a beginning of the existing linked list. Yes or no? It is possible or not? For example, one queue is there. In that queue, you can join first also. You can go and you can stand in the first also. Yes or no?
Yes, sir.
Yeah, you can insert this new node as a last node also. Yes or no? You can insert this 50 as a last node, as a first node. Or as per the discussion, wherever you want to insert, you can insert. There are three ways you can insert a node in a single linked list. Accepted?
Yes, sir.
Yeah. We can insert a node in a three ways. Inserting at beginning of the list, inserting at end of the list, inserting at specific location in the list. Clear? Clear?
Yes, sir.
For this, three functions I am going to declare. The first one is inserting at beginning of the list. Here, inserting at beginning of the list. Now, I want to insert a node beginning of the existing linked list. Right. Now, ADT is created, right? Here, ADT is created, right? Means this program, it is going to create an ADT, abstract data type is created for single linked list. Yes or no?
Yes, sir.
But we are not allotted memory dynamically for this because initially it is null. We are not allotted memory. We are not inserted any data here. And we are not inserted any link here. Yes or no? Just structure is created. ADT is created. We can use. After that, we can, like how we are using int A, we are not initialized any value to A, right? Same way, we are just created structure. Yes or no?
Yes, sir.
Now I want to insert a node beginning of the list. So if you want to insert a node beginning of the list, we have to first insert the data and insert the address part. Then only we can use. Before that, we have to add the, means allot the memory dynamically. Yes or no?
Yes,
Still
sir.
we are not allotted any memory, right? We have to allot the memory dynamically. Yes or no? For that, we use mallot method. Clear? Clear?
Yes, sir.
Yeah. Sure, ADT is ready. Now I'm going to insert a beginning. Sure, now this beginning, before inserting, you must add the data and add the memory and add the address for next part. Okay. Now, for that, here the first instruction is what? Sure, this is very important. Already I told you, whatever the code in single linked list I am going to discuss, 90% of the code you can use all the data structures, entire our data structure subject. Please follow. Okay, this I will close. Anyway, time is 12. I will close after this. At least we have to add this data. Then tomorrow we can, next class we can inserting, we can discuss. First of all, this code is common, very important for all. Just then practice it in your home. Just structure node NN. Here means what we are preparing here, we are creating object. NN means I am thinking it is a new node. Okay, structure node NN. What is this? New node is a NN. Structure will come like this. Yes or no? Outside of the structure I am calling, I am creating object for node structure. Yes or no?
Yes, sir.
Now clear? Clear. Now structure is came. Here this first part is for data part, second part is for next. Correct? Is it right?
Yes, sir.
Yes, sir.
Right. Now we have to allot the memory for this structure. Yes or no dynamically? Yes or no? Please respond fast. Yeah. Now for that I am using malloc. Malloc means memory allocation. Yes or no? What is the syntax of malloc method? What is the syntax? Already you know dynamic memory allocation in your C programming. What is the syntax? What is the syntax? Time is running. No response. What is the syntax? No one is there. Are you there? Are you clear my question?
Yes, sir.
Yeah. What is the syntax of malloc? That is what prerequisites I mentioned along with my invitation. Here, what is the syntax of malloc? Malloc syntax is when I want to allot memory to some variable, for example, a equal to malloc of size of 4 or size of 3. If I write malloc size of 3, if I write what happened, 3 bytes of memory is allotted to a dynamically. Whenever I want to use a, dynamically it will come. After execution, it is going to, again, it is going to delete it. Yes or no? Yes or no?
Yes, sir.
Yeah, the same syntax I am using here. Here malloc, here size of. Here I am not specifying the number. Why? Because I know what is the size required for this structure. Yes or no? Because it is not a predefined one. Just we are constructing ourselves. Yes or no?
Yes, sir.
That's why here how much size I want. Here you have to specify size. How much size I want? The node structure, struct to node size I want. That's why I'm specifying here struct to node. Instead of writing number, I am writing struct to node. Are you clear now?
Yes.
Yes, sir.
Are you clear? Directly, whenever the operating system is going to automatically calculate the structure, because the structure already we are declared. So how much memory is required based on the situation, it is going to define. You no need to think about how much memory will come. That's why here malloc of size of struct node. Instead of writing number, you can write struct node. Are you clear now?
Yes,
Are
sir.
you clear?
Yes, sir.
Now, here what type of memory data it is going to store? What type of data it is going to store? If I am going to write malloc of size of 4, here it is going to allot 4 bytes, maybe the integer, if the variable is a. But here this NN, I don't know what type it is. This NN is struct node type. Then this NN required, what type of structure of memory is required? Struct node type. That's why you have to specify externally type conversion function that is struct node star. Are you clear for this dynamic memory allocation now? Are you clear now this dynamic memory allocation?
Yes, sir.
The simple meaning here malloc of size of struct node. How much size is required? That size is going to calculate it. That is going to allot it. And also you need what is the type of this struct node. That's why externally you have to specify type conversion. That is struct node. Before malloc function you have to write struct node star. Then automatically it is going to convert what type of data we are going to allot for this particular NN. Here now we are going to assign this to NN equal to struct node of malloc of size of struct node. Means it is going to allot the memory dynamically whenever it is going to require. The size is struct node, the type also struct node. Now clear this?
Yes,
Yeah,
sir.
now memory is allotted dynamically for this NN. Yes, NN is there, memory block is there, your classroom is there. Now we are going to arrange. Here how to arrange this part. What is this part? This part is for data part, right? We declared very clearly here into data, struct node next. Now this is a variable data. The first part is for data. Okay, that's why we are going to enter the data. Okay, that's why using printf and scanf statement, what we have to enter? Here, enter data percentage address of NN data. This is address of NN data. Are you clear?
Yes, sir.
Now, if you are entered 10 here, because it is scan function, right? Here 10 will be stored into the address of NN data. Address of NN. This is NN. Address of NN data. Pointing to data. Pointing to, this is going to point address of NN next. Are you clear? Now we are storing 10 here. When we are going to execute this program, what it is going to ask? Enter data. It is going to ask. You are entered 10. 10 is going to store into where? Address of NN data. It is going to store in a data part. Clear now? Clear
Yes,
now? This is a new node. The data part is 10. Now, next one is, next we are storing NN next equal to null. NN next, this is NN next, right? NN next, right? It is going to store what? Null. Clear now?
Yes, sir.
Clear now? Just NN data I am storing. This 10 I am storing A for other purpose. I will tell you why I am storing this. The main instruction is here now node is created. Here new node is created, memory allotted, data is inserted, and pointer means that address also assigned. Is it clear now? Node is ready or not? New node is ready or not?
Yes, sir.
Yeah. Whenever you want to insert a node wherever you want, compulsory you have to prepare a node like this. Are you clear? Call the abstract data type. After that, allot the dynamic memory for that. After that, insert the value for data part and assign the address to the address part, next part. Clear? Clear everyone?
Yes, sir.
Everyone, is it clear? After that, we can insert this node wherever you want. Clear this? Tomorrow we'll insert. Is it clear everyone?
Yes.
Yes, sir.
Yeah, just I am stopping the session. Okay, how to create a node you can understand based on this lecture. Next